Today we're going to, for the first time, do moles to grams using the coefficients in a balanced equation. And what we're going to do in the first couple of problems here is just one section of the big picture. And I'm going to narrow that little section down here with the blue box, and you can see that we have particles on the left that we haven't dealt with. That doesn't mean we can't convert to particles anymore. It just means that we're not using them yet. And the book is very nice. They start you out with just mole-to-mole stuff, and then they expand it for you to make conversions all the way from moles of one kind of stuff that I called A to moles of B, and then we're back in really familiar territory. Isn't this familiar territory, the chart? Yeah, really familiar territory. Okay, what we've been doing with most of our calculations up to now is this stuff, right? This was the big picture before, the green. All right, now we have gone and added another mole step between particles and moles. Or we could look at it the other way, is we've added another step to moles, going from grams to particles. But for right now, we're just going to focus on this one little area, and we're going to look at mole-to-mole relationships. And so let's go and look at the first practice problem that I had for you to demonstrate this. And I'd like to call on someone to actually figure out what the fraction is that we're going to start with. Okay, the first fraction in all of these calculations is going to be exactly the same. It's always something over 1. So how are we going to start this particular calculation? Okay, what's on the top of the first fraction?
Okay.
There you go. Okay, 3.5 moles. You just panicked a little bit, that's all. There's your first fraction. All right, now comes time to figure out the second fraction, and that's going to have everything to do with the arrow that you see up here between the hydrogen and oxygen in the balanced equation. So I've focused us here on what the actual mole ratio is going to be. So we're given, and the mole ratio is always determined by given and find. So you know right away what to look for in the balanced equation. So we just go down here, we find out where the hydrogens are, moles of hydrogen, and we see that that's going to be here in the balanced equation, and then we're going over to oxygen, which is here in the balanced equation. So Lizzie, can you tell us what has to be on the bottom of the next fraction? I'm asking you to focus on units of measure and substance. What has to be on the bottom? What is the coefficient of hydrogen? Okay, you want to amend that? Yes, 2 moles of hydrogen on the bottom, and what's on the top? Okay, there you go. Yeah, you got there. So it's 2 oxygens, and that's what it looks like. But it's not 2 oxygens. 2 oxygen atoms, but it's 1 oxygen molecule, and so it's 1 mole of the molecules. And the 1 comes from the coefficient that's not here. Yeah? Yes, Robert? Yes, the 2 moles on the bottom came from this number right here. You bet. And now all we have to do is calculate. And that looks like this. Okay? Now we're going to do a second problem with Okay, here's the side by side. We have a problem here that we just completed, and then we're going to go ahead and go to copy V. We're going to go to this problem over here on the left, and let's look at what the differences are. Has the given changed? No, it has not. So the given in both problems, let's put this guy up here, and see, here's the given over here. Those givens are identical. What did change? Okay, and notice we're doing moles of A to moles of B again. So the find is different, and that's going to determine our mole ratio. So Natalie, would you do this one for us? Okay, Natalie, what are we going to have in our first fraction? And let's change this guy over so that we can take him full screen. Okay, what's our first fraction have to be here? Good. And since this is so similar, let's go ahead and do the second fraction also. What has to be on the bottom? Good. 2H2. She looked at the balanced equation. She saw that we were dealing with H2. That has to be 2 what of H2? Moles. Okay. If we did not write the word mole here, for instance, and we just wrote it 2H2, or in this case 3.5 H2, that would be 3.5 molecules of H2, as opposed to moles of molecules, which is 6.02 times 10 to the 23rd molecules. Okay? So it's important to put the moles in. And what's on top? Okay, and what's the number that goes with it? 1. Very good. And there we have it. Now, for this problem, we need to go back and now look at what it is that we're doing in the big picture. This problem's a little bit different, isn't it? So, what have we done so far? We started here, and we have just converted. Where are we? Are we here or are we here? We're right here, aren't we?
Yeah.
Okay, so I need someone to tell me, Lewis, could you tell us, how are we going to get this thing to grams? Huh? Oh, no. We got to get to grams. You're not going to divide moles into moles and get grams. Robert, what do you think?
Get rid of the hydrogen and get the oxygen.
Okay, let's see what we've done so far. We canceled moles.
You're left.
We canceled hydrogen. So all we have right now is moles of O2 is the only unit of measure. But the problem is telling us that we have to get grams of oxygen.
But don't get 2 moles. That means you have 1 mole left.
2 moles of H2? Where?
On the bottom, like right.
The 2 isn't crossed out, just the moles of H2. So we have a half mole of O2 in that box. Okay? So, how are we going to get moles of oxygen to grams of oxygen? Huh? Chart, of course. And the molar mass of oxygen is 18 grams, so what's going to go where? What's on the bottom?
It's 16.
What did I say?
It's 18.
18. I'm wrong. I was thinking water. Okay, good. So we're going to have 16 for 1 oxygen, but we have O2. 32. Okay, so we have 32 grams of O2, and where's the 38 and where's the 1 mole? What goes on the bottom? 1 mole of O2, and what goes on top? 32 grams of O2. Yep. Okay, and when we run the numbers, we come up with 56 grams of O2. Okay? And that's about as tough as it gets. Let's try another one. Let's go back and try another one of the first kind. Mole A to mole B. I've left the given the same in all of these because I want you to see what happens if we're asked to do different stuff. See, in this one, we were asked to do hydrogen to oxygen, and in this one, we're hydrogen to water. So the mole ratio is going to come from here and here, because given and find are taking us from here over to here. And so hydrogen has to be on the bottom to cancel the hydrogens here. And so what can we cancel here? Moles and hydrogens and hydrogens. And can we cancel anything else right now?
No.
Come on, what can we get out of there? The twos, right. So get rid of those guys. And now, in this problem, we're done. Okay, so look at these two guys side by side. And here we go. These were the mole A to mole B. And this focuses to see where it is that we are on the big picture. When we went to this one, we then made this box bigger. And the blue box got bigger, didn't it? Oh, not here. Not here. Oops. We're still here. Let's go back this way. Come on. Let's go. All right. Now, in this one, this is where we got the box bigger, and we wound up going to grams. Let's do another one where we're changing and going to water. Okay, did we do this one? I don't think we did this, did we?
No.
Okay, let's check it side by side now. The first fraction, same as it has been for all of them. Second fraction, we are this time doing water, and I think I've still got an arrow in there. I do. How nice. Okay, so we've got the water on top. That came from here. We got the H2 on the bottom. That came from here. Water, hydrogen with 2, water with 2, and just like these guys over here on the left side, in the prior problem, instead of being able to back on the left-hand side, I couldn't, this 2 had to stay. But over here, the 2 can go away. On the right-hand side, and moles again can cancel, hydrogen can cancel, and now we're at moles of H2, which puts us right here, moles of B. Yeah? We changed moles of A to moles of B. That's what we did with these two fractions. Now we got to get to grams again. Only this time the molar mass is different, isn't it? Now we have a molar mass of water to worry about. What is that? 18. Yeah. So getting the moles down here so it cancels. And we can go ahead and cancel that out. Moles of H2. We cancel the substance and the moles. And we're left with grams of the new substance. And the answer turns out here. And that's it. I hope you find this helpful. Notice that on this first homework problem, on number 9 out of CMC, you have actually 2 problems. When you look over here, they don't even give you, in number 9, there is no balanced equation. So I took the liberty of providing you with that. Okay, so there it is. You have your balanced equation, and I've also written in the arrows for the two mole ratios that you're going to need. You can see what you need for A because you have, there we go, right here. This A tells you that your ratio is from sulfuric acid to sulfur dioxide. And by the way, this is the formula for acid rain. Why? Because SO2 is being produced. It goes into the air where it can meet up with our friend oxygen, our friend and our savior. Without O2, you would be dead very quick. Very quick, yes. This will be, yes. And so these guys get together along with water, which is also sitting in the atmosphere, and it makes sulfuric acid, and then it rains down all over you. Yeah, wow. That deforests, that will take the leaves off the trees and actually ultimately destroy the trees. This is a forest destroyer. And there are certain chemical manufacturers or people make stuff that has the SO2 as a byproduct, and that SO2 is very nasty stuff. And when it rains sulfuric acid. Not nice. Anyway, so you have how many moles of sulfuric acid can I make with 12.5 moles of sulfur dioxide? That's your letter A. And notice the given is the same for both of the problems. You have the same for A and B for your given, but different finds. And that's why I drew arrows in two different places here. So you get to do the problem. Have fun. See you in class.